Lesson 22, Analyzing and Comparing Statistical Graphs. You see here in our new concepts portion, it's asking us to learn about the different types of graphs, which we've studied in math and in science, and to then be able to analyze those, as in pick out what information is being conveyed mathematically, and being able to answer questions corresponding to those graphs. Numerical data can be displayed in different ways. Bar graphs use vertical or horizontal bars to represent data. We learned that the way in which a bar graph shows, it's a comparison of two different variables. So in this example, you've got number of students and type of pets, and specifically a bar graph allows you to take one of those variables, the type of pets, and turn it into multiple categories. Here's what you see happening here: dog, cat, bird, hamster, fish, and people filling out which of those is their favorite. Giving you this information, you can answer some questions. In our exploration here, it says A, what information is shown on the vertical axis and the horizontal axis? Well, on the vertical axis, you've got the type of pets. On the horizontal axis, you've got the number of students. Those are the two variables being compared. Letter B says use the graph to complete the table. So how many people pick dog as their pet, the number of students? You'd have to go over here and take a look from 0 to 150, and then it's between 150 and 200. Now, we'd obviously like our graph to be a little bit more detailed so that you could pick this point out. In this case, you're just going to take an educated guess and estimate. Maybe that's around 160, 170. Probably 160 is probably our best bet in that guess. For the number of cats, you're here at 150, back a little bit, maybe 140. For birds, you're not quite to 50, so maybe 40 birds. Hamster, you're at 50, 60, 70 people voted for hamster as their favorite pet. Fish, 50, 60, 70, 80, maybe something close to 90 as an educated guess. We'd obviously want our graph to be more detailed to show those points. You can make more educated measurements, but here's just the way in which you're going to have to be able to use that skill of estimation in the form of reading a graph. Letter C says how many students were surveyed. You'd have to add the total of every one of those values. So we took a guess and said 160 plus 140 plus 40 plus 70 plus 90. It would be a total of 500 if you added all 5 of those points up. 1, 2, 3, 4, all 5 of those answers put together would be the total number of students surveyed, which would be close to 500. Which pet did students choose twice as often as the hamster? Well, the hamster was only up until about 70, so twice that was the cat. Was 140. You have to be able to use some of this information and answer those questions specific to what's being presented in the graph itself. A double bar graph shows groups of 2 bars side by side. This allows an easier comparison of 2 sets of data. So here, for example, you again have variables that are being presented in each axis. You've got the number of sandwich shops, and then you've got the year. And then because you're using a double bar graph, you can compare 2 of those different types of sandwich shops in the same year. Here's the example of Sal's Deli being compared to Harry's Deli, and how many of those shops, how many of those maybe franchises that those people have as their businesses grow or decline. Sal and Harry both own sandwich shops. The double bar graph shows the number of shops they owned at the end of each year. What conclusion can be made from this graph? Our solution, you'd say that looks like Sal's Deli was a smaller company. There were only 2 shops in comparison to Harry's Deli, who had 8. It looks like Harry's Deli continued to grow up until 2006. So over the course of 5 years, a lot of these places were opening. There was more and more of these restaurants for Harry's Deli. Sal's Deli, on the other hand, went from in 2001 to having 2 all the way up to having 14, but then declined a little bit and had some of those shops closed down, maybe because of economic activity or the way in which those businesses were run. You saw an incline, an increase in those activities, and then a decrease. The solution in your book describes it in this way. Harry always had more shops open than Sal, except in 2004 when they both had the same number of shops. The number of shops Harry owned increased from the years 2001 to 2006. The number of shops Sal's owned increased in the years 2001 to 2004, but decreased from the years 2004 to 2006. So you can use this graph to answer those questions or to describe the way in which the data is showing trends or answers to the questions. The next type of graph or mathematical calculation of data is a stem and leaf plot. A stem and leaf plot is a data display that uses digits as stems and others as leaves. The stems have a greater place value than the leaves. Stem and leaf plots are useful for organizing and ordering data. In example 2, you're interpreting a stem and leaf plot. That example is right here. Stem and leaf plots show the age of members of a hiking club. Here you've got the stem being 1, 2, 3, 4, 5, but that's not meaning that they're 1, 2, 3, 4, or 5 years old. That means that they're in terms of every tens of that year. So find the age of the members of the hiking club that occurs most often. Here in this case, the age that is here, 1, 0, it means 10, 10, 17, 24, 26, 32, 33, 34, 41, 41, 41, 43, 53, 56, 56, and 59. Okay, here's the entire data set written out, which one occurs most often. There are 3 members of the hiking club that were 41 years old. You'd see that by here. 41, 41, 41. There are 2 people who were 10 and 2 people who were 56 in that age group, but the greatest prevalence, the most of them, was the 41-year-olds. In a line graph, a line is drawn through points on a grid to show trends or changes in data over time. Line graph shows a comparison of 2 variables, and a lot of times it shows this upward or downward trend on what's happening in between when those points of data are taken. As with bar graphs, 2 related data sets can be compared. If you use a line graph and then a double line graph, you can have 2 lines that compare this back to back. In example 3, you're interpreting a line graph and a double line graph. In this case, we're going to look at the exact same information between Sal's Deli and Harry's Deli. It maybe is easier to see the trend on a double line graph in comparison to how the trend here shows an increase and decrease. If you break it down and look at just one of the light blue bars, you can maybe see that. But the blue bars kind of go up and it kind of confuses what that looks like. The line graph maybe shows that more accurately in terms of the number of shops that they had open. So here again, it asks what conclusion can you have. Those conclusions should be exactly the same based on them being the same information. You're just being asked to answer questions from those graphs specifically. In example 4, it asks you to break this down with a table here that has the months, deposits, and withdrawals. And it's talking about Andre's bank account transactions. It says make a graph to compare the deposits and withdrawals. So you're comparing these with the bar graph. The light blue is the deposit, that's money going in. The dark blue is the withdraw, money going out. Hopefully the money going in is more than the money going out, otherwise he's spending above his means. He's living too fancy a lifestyle in order to pay for the things that he has. He's spending all the money that he makes. He's not saving or investing any of that kind of stuff. Here in this case, it says make a graph, use a double graph to compare the deposits and withdrawals. This graph shows that the deposits were greater than the withdrawals in January, April, and May. The withdrawals were greater than the deposits in February and June. Andre deposited and withdrew the same amount of money in March. So deposit was larger, withdrawal was larger, same amount, deposit was larger, withdrawal was larger. Sometimes you spend more money than you make in that month, and you've got to rely on the savings that you had from previous months. Basically, our math class today is being able to interpret what's being presented in those graphs, and because you've already learned what those graphs do, you can see specifically how that works out for us. The last one that we have as an example is a circle graph, and we know that a circle graph uses sections of a circle to compare parts of the circle to the whole circle, parts of the whole. In this case, you take the overall fraction of that entire probability or the fraction of that graph, and you can turn it into a pie piece based on calculating 360 degrees or 100% of what that whole or total is. In this example, you have a circle graph showing Art Online's total yearly sales by quarter. Total amount of sales for the year was $20 million in art, so fancy dancy paintings and sculptures and things that are being sold and traded on this website. They sold $20 million worth of art. Here's when they sold that money. In the first quarter, they sold 12% of their sales. In the second quarter, 32%. In the third quarter, 13%. In the fourth quarter, 43%. Now you're going to take that percentage and multiply by 20 million. You can turn that into actually what actual amount that is for each of the different parts of that 20 million. Our lesson practice problems come right from the examples that we looked at. So in these, you're going to have to maybe go back and see what those graphs were representing. In example 1 from letter A, it says use the double bar graph in example 1. What year shows the greatest difference between the number of shops Sal and Harry owned? So I should go back up to where it has Sal and Harry's graph from example 1. What year was the greatest difference? So the greatest difference means you've got to subtract the highest amount from the smallest amount. Which of these shows that big difference? This one looks like a pretty big difference because you've got 18 and 7. That would be a difference of 11 if you were subtracting those. There's a difference here, but it doesn't look like it's as large. So we're going to go and say 2006 was the year in which they had that greatest difference. And it says what year shows it, so 2006 was our answer for letter A. Letter B says use the double line graph in example 3. What was the greatest number of shops Sal opened in 1 year? The double line graph from example 3 is like right here, what was the greatest amount that he opened in 1 year in sales? So you're looking at where was that increase? Where did it go up from 1 year to the next? So here we were at 2, we went up to 5, so increase of 3. From 5 until 9, increase of 4. From 9 until 14 is an increase of 5. That would be the greatest increase so far. These are obviously decreases because they're going downwards. So for letter B, 5 was our answer. Letter C, make a stem and leaf plot of the data showing the height in inches of the grandchildren in the Jackson family. Here it's asking you to take 52, 56, 68, 49, 49, 40, 72, 71, 43, and 54. What height occurs most often? So you're going to go and you're going to write a stem and leaf plot like this, giving that you've got tens values and ones values written as the stem. The stem is the tens values, the leaf is the ones values. In this case, you would have 40s, 50s, 60s, and 70s. So on this part of the graph, you'd write 4, 5, 6, 7. And on this part of the graph, you'd fill in where those values are. So in the 40s section, you'd have 40, 43, so 4, 3, 49, 49. In the 50 section, you'd have 52, 56. In the 60 section, 68. And then in the 70 section, 71 and 72. What height occurs most often? You've got, for letter C, 49 inches. Letter D, use the data in example 4. Which month shows the greatest difference between deposits and withdrawals? In this case, you're looking for the greatest difference. Difference means you're going to subtract. Again, you're using the question and the graph to solve that question. So find the greatest difference between those. If we go back up and look at example 4, where do we have the greatest disparity, the greatest difference between those items? That's what we're looking to find that, and then we'll calculate that difference. It looks like in January you've got this huge spike in deposits and this very little amount of withdrawals. That looks like the greatest difference or the biggest gap between where those two bars are. We're going to say January. Letter E says predict. Use the circle graph from example 5. If the first quarter sales the next year are 3 million, predict the total sales for the next year. So let's see. Here in the first quarter, 12% was worth 2.4 million. So if 3 million is that new sales, you're going to predict maybe that there's that same increase. So 2.4 to 3 million is an increase of $600,000 or a pretty decent percentage of that overall amount. And in this year, you sold 20 million and you went up. Maybe you're going to sell between 23 and 25 million as a way to estimate that overall. Again, today's lesson, you're going to take the graphs information, and then from that graph's information, try to solve the question that's being asked or proposed. You know what each of these graphs does. A bar graph shows comparison of those two variables, maybe even with multiple categories in that variable. A line graph shows a comparison of those two variables. A stem and leaf plot shows the data in order from smallest to largest, with the stem being your tens value or your greatest place value, your leaf being the smallest place value. You can turn a line graph or a bar graph into a double line graph or a double bar graph that allows comparison. And you can use that to answer questions or to solve or find information from what's being presented in that type of graph itself. Lastly, we learned about circle graphs, in which they're part of the whole. We obviously know how to do and calculate the different types of percentages for these, the 360 degrees or the 100%. And then we can take that information and, again, answer questions about that type of data that's presented as you're comparing parts of a whole. Hope that helps you complete your assignment. God's blessings.